All right, here we go, guys. Today we got parallel lines and perpendicular lines. And we're going to talk about the lines, angles, and the different pairs that you have. Okay, so first of all, the first main thing that we want to talk about is this thing called a transversal line. So a transversal line, what it does is it intersects two other lines that you have going on right there. So this is kind of a good picture based off of that. And we're going to use our transversal line to name a couple different angle pairs. So the first one that we talk about is the corresponding, be the corresponding angles right there. And you want to think same relative location or same relative position here. So check this out here. 2 and 6, those would be corresponding angles. That'd be an example of it. Key things you want to notice here, they are both above your two lines that you have. And then here's your transversal going on here, and notice that angle 2 and angle 6 are both on the same side of that transversal. So we call that corresponding angles there. So essentially they're kind of like in the top right and then the top right. Another example of it, you could say like maybe angle 1 and angle 5, and then we'll go get the rest of them here in just a moment. Okay. Next you have alternate interior angles. All right, you want to think opposite sides, but between your two lines that you have here. So here are your two lines. You want to think about being inside those two, and then opposite sides of your transversal there. So if we're thinking about that 3 and 6 right there, those would be a good example of alternate interior angles there. Another pair would also be 4 and 5 right there. So you want alternate sides of the transversal line, and that's this line right here, and then inside the two other lines right there. Alright, next you have alternate exterior angles, very similar. You want alternate sides of your transversal, but since they're exterior, you want them on the outside. Alright, so all of your exterior angles, if you look here, you got 1, 2, 7, 8. Those are all the angles on the outside of your two lines. And then you want alternate sides of your transversal. Whoops. So an example of that, you could say 1 and 8. Those are opposite sides of that transversal and on the outside. Another one you could do is angle 2 and angle 7 right there. So those are examples of alternate exterior angles. Alright, next one, same side interior, and sometimes you'll see this as consecutive interior angles. And those are same side and then between your two parallel lines. Alright, so kind of similar to, I guess, alternate interior angles. They're inside, but now they're on the same side. So all of your inside angles, you could say those are like 3, 4, 5, and 6. Those are all the inside angles. And you want on the same side. So 3 and 5 together, those would be inside angles on the same side of your transversal here. Or you could also go with 4 and 6. Those are same side interior angles. Alright, couple other things we'll talk about. Parallel lines, two or more coplanar lines that never intersect. Skew lines, these are non-coplanar lines that never intersect, and we'll see an example here in a second. And then you also have perpendicular lines, lines that intersect at a 90-degree angle. Most have proof. I'm not sure why that is there. I guess it's saying it needs to be marked, I guess. So the diagram below shows 8 angles formed by a transversal on the two lines. So we will go ahead and put in a couple of the different ones here. So you got corresponding angles. Now, I'm not going to put every single corresponding angle pair, but you could go like angle 2, like we talked about, and then angle 6. That's an example of a corresponding pair. Now I'm going to do just one more. Let's go with angle 3. So then you would need that bottom left one as well. So angle 3 and angle 7. Those would be corresponding angles. Okay. Next one, alternate interior. Now you only got a few pairs of these here. Alternate interior, so inside your two lines, alternate side of your transversal. So that would be something like 3 and 6. Angle 3 and angle 6. And then another example would be 4 and 5. Angle 4 and angle 5. So yeah, there's only 2 of those there. Alternate exterior angles, so all these outside angles here, if you're looking at those, 1, 2, 7, 8. Alternate sides of your transversal. So you want to be on opposite sides there. So 1 and 8 would be an example. Angle 1, angle 8. And then also you could go angle 2 and angle 7. Alright, and then you got same side interior. Kind of just talked about that. So we can say angle 3 and 5 for that. Remember, you want same side of your transversal and then interior angles going on right there. So inside those two lines. It's 3 and 5, and then also the other combination would be 4 and 6. And those are the main types that we talk about. I've heard some students say something, well, what about, same side exterior and stuff like that? And, I guess, if you said that in math class, we'd probably be able to figure out what you're talking about. But these are the main ones that we focus on in this class here. So I'm going to go ahead and move along here. Find a line or plane in the figure below that fits each description. And this is where I think we start talking about the skew lines. So let's see here. So we got parallel to the line MN. So I'm going to highlight that. MN, there it is. And then it also contains J right there. So if we want to go parallel right there, we want to make sure that the parallel lines, we assume those to be coplanar there. So I need to make sure you could get a plane going through these right here. So JL looks like my best option there as far as the line goes. Now skew to MN and contains J. Alright, so this is where it's a little bit different here. You want non-coplanar lines. So lines that technically never intersect, but they're going to be going in different planes. So that's the answer there. That one's JK. So if you notice that, one of them's kind of like going up and diagonal, and then the other one's going straight up. Yes, they'll never intersect, but they're actually not in the same plane either. So these are non-coplanar right there. Usually when we think about parallel, usually we think side by side and going in the same direction, but these kind of are going, these never intersect, but they're not necessarily going in the same direction. So kind of a weird concept there. Perpendicular to MN and then contains J. That would be probably this right here. Now, technically, I guess we need a right angle right in between there, and they didn't mark that, so I think that's just a typo on our end right there. We need to have that right angle marked there. So perpendicular to MN, maybe we could even say looks perpendicular if we want to get a little bit more accurate there. Looks perpendicular to MN, and then contains J, so that would be JN, like we talked about. And then name the plane that contains J and appears to be parallel to plane MNO. So that looks like that's the back face right here, if y'all kind of look at that. So parallel to that plane right there and contains J. So that looks like it's going to be this side face right here. So we can say that that is plane JKL. Okay. So now actually we're going to switch gears here. We're going to go back to all of our angle pairs that we just talked about, and then we're going to talk about what happens when the transversal, when the transversal that cuts the lines, the two lines happen to be parallel, and how that changes the stuff going on here. So imagine that these right here are going to be parallel lines, and we can use some properties here after that to talk about all the different angles. So when two coplanar lines are cut by transversal are parallel, the angle relations have additional significance. Please note that regardless of whether the lines are parallel, angle pairs retain their names. It is only their properties that have additional significance. Alright, in the proof, the blank statement must be used when justifying a conclusion involving parallel lines. This is going to be a conditional statement. Alright, I'll talk about what that means. If you're using parallel relationships to conclude angle relationships, your sentence must always begin with if lines, or I guess I should say if the lines whatever the lines are. And you can use this symbol here for parallel. If the lines are parallel, then your angles, and you got to talk about your angles. So like an example would be like then your like alternate interior angles are going to be congruent. That's the way you write it out in a proof. And I believe we do get into that a little bit more tomorrow, so we'll see that. So anyways, we'll talk about some of the properties here. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are going to be, and this symbol right here means congruent. So these two will be congruent if the lines are parallel. And by the way, these little triangles here that are kind of filled in on the two lines, that means those lines are parallel. So we'll say parallel. Alright, so that's with alternate interior angles, and once again, that's only if they're touching parallel lines. Okay, also you got corresponding angles theorem. So after that, you can also talk about if two parallel lines are cut by a transversal, then the pair of corresponding angles are, we're going to say congruent. You know what? I put parallel up here. I'm sorry. That should be congruent. Should read that. Then the pairs of alternate interior angles are congruent. My bad on that. Anyways, corresponding angles theorem. Yep, so anytime you have corresponding angles touching parallel lines, got some congruent angles going on right there. Alternate exterior, same thing. If you got alternate exterior, you're going to have some congruent angles right there. Alternate exterior angles are congruent. Now here's to the last one here. This one's a little bit different here. If two parallel lines are cut by a transversal, then the pair of consecutive interior angles are supplementary. So this is where it's a little bit different. Which, remember, that means they add up to 180 degrees. So 3 and 5. This is only same side interior or consecutive interior. Alright, on another sheet of paper, write a paragraph proof justifying the relationship for 3.1, theorem 3.1, using 3.2 if the lines P and Q are parallel. So we are justifying 3.1, wherever that is, theorem. Oh, there it is. So we're going to justify alternate interior angles being congruent based off of theorem 3.2. Okay, so there we go. So I guess we're going to assume corresponding angles are congruent, and then we're going to go and prove that angle, or I'm sorry, theorem 3.1 is also true right there. So corresponding angles are congruent. Okay, so I guess if we're going to do a paragraph proof, we can say we are given that the lines, I guess, are supposed to be P and Q because they're a little bit off there. So we're given that lines P and Q and Q are parallel. And then once again, we're using 3.2 right there. So we'll say since angle, wait, what are we doing here? Oh, corresponding angles. So we need to look at our corresponding pair. So 1 and 3 right there, those are going to be congruent based off of theorem 3.2. So we'll say since angle 1 and angle 3 are corresponding angles, and then I guess we should say and touching parallel lines, they are congruent. So now we know angle 1 and 3 are congruent. Okay. Now we're going to say angle 1 is congruent to angle 2 since they are vertical. And then we can say therefore we can say angle 1 is congruent to angle 3 by the transitive property. And then that would be the end of your proof right there. And then we essentially just proved one of the theorems. So there you go. There's your paragraph proof there on that by using your transitive property. So, and actually, you know what? Actually, I should say angle 2 and 3 are congruent. I'm sorry. If 1 is congruent to 3 and then 1 is also congruent to 2, then it should have been 2 is congruent to 3. So there we go. Okay. Also, parallel lines can be marked in a number of ways. Sometimes it'll be given as a statement. Some of the geometric markings indicated by parallel lines can look like this right here. And as I said, it's a little filled in triangle on the lines. That means that these two lines will be parallel, or these two lines will be parallel. Or this one right here, there's the two markings there, so these two lines are parallel. Alright. Got a couple more here, so the rest of these here, now I guess we are going to solve some equations out and using the idea that these lines are going to be parallel, so then we can say, well, then you got values of x that you can go find. Alright, since those are alternate exterior angles, those are going to be congruent. So you can go 113 equals 3x minus 4, and then you can go through and solve that. Alright, you solve that by adding 4 to both sides there. That'll be 117 equals 3x, and I'll go ahead and use a calculator here real quick so I don't have to do any thinking. And x is going to be 39 in that case. Actually, not even degrees, it's just x equals 39. Okay, so there you go. I mean, these are pretty easy here. You just got to figure out what the relation is right there. Those are corresponding angles. If corresponding angles are touching parallel lines, then those are congruent. So we can say 111 equals x plus 21 there. And then I guess subtract 21 from both sides there. And you get something like 90 right there. X is 90, so when you plug it back in, should all work out. What do we got here? Okay, find angle 1 and angle 2. We'll check this out here. Angle 1, don't forget about that relation there. That right there those are vertical angles there. So angle 1 should be 56. And then also 1 and 2, those are alternate exterior angles. You could also say 56 and 2 right there. Those are corresponding angles. Regardless, all of this stuff here should be 56 degrees. Okay, now let's talk about one we hadn't seen yet here. Look at these. These are same side interior. So when you have same side interior angles, you can say the measure of angle 2 plus 60 right there should equal 180 because those should be supplementary when you have parallel lines. So the measure of angle 2 should be 120 once you subtract. And then also you can find the measure of angle 1 by using a linear pair, and then you get 60 degrees there. Those are your two angles there. And you can also say alternate interior angles are congruent whenever you have parallel lines, so you could say 1 is equal to 60. Okay, let's look here. You got alternate exterior angles going on right here, and those will be congruent. So I'll set those two things equal to each other. And once you divide, you get x is equal to 36. So that one wasn't too bad there. Alright, so these are just, these are all kind of similar here in a way. Now this one here is a little bit different here. We got to be kind of clever on this one here. So check this out here. You got 64 degrees, and then you got the 4x minus 8. Now, since this angle right here is 64 degrees, I can go and place that in a corresponding location right there. So I'm going to say this corresponding angle is also 64. Therefore, those two make a linear pair. So I'll go 4x minus 8 plus 64 then equals 180 right there, since these two, once again, make a linear pair. So that one you got to kind of move the angles around to get them in the right spots there for that. So when you combine like terms, that's 4x, and then a plus, what do we got, 56, and then equals 180. So then you're going to do 180 minus a 56, and then eventually divide. So you get 4x equals 124, and then divide by 4, and then that gets you x equals 31. So that one's a little bit more involved, so we got to be kind of careful on that one. And I think this next one here is very similar. What do we have? X plus 5. So I'm going to go put that up here, x plus 5, because those are corresponding angles and they're touching parallel lines. Therefore, you can put x plus 5 right there, and then you got a linear pair going on. X plus 5, and then plus 3x minus 7. And then that should equal 180 degrees. This is 4x. This is minus 2 equals 180. And then add the 2, 4x equals 182. And then 182 divided by 4, you're going to get 45.5. Alright, just a couple more here. This next one here looks like you got your two parallel lines. Notice that you got two different transversals. You got this transversal line, which actually kind of looks more like a segment, and then you got this other one going on here. So the first thing I notice right away is you have your two lines and then your transversal right there. So angle 1 and the 68 degrees, those are going to be alternate interior angles, because there's your two lines and then your one transversal there if you want to extend them. So anyways, one should be 68 degrees because of alternate interior angles. Now check this out too. You got the 105 going on right here, and that's touching a different transversal. Notice it's right over here, and those actually look like some same side interior or consecutive interior angles. So we know that those should be supplementary. So I'm going to go ahead and do 180. I'm going to subtract off the 105, and that'll get my angle of 75 degrees. That'll be your answer there for that one. So that's all you do there on that one. So it's a closed figure, so we kind of got to, still think about our rules about our transversals and your two lines. So anyways, next one here. This one's a little tricky here, so I'd put a star next to this, because this one right here, notice you got this 15x going on right there. It's touching one of your lines, and there's your other line, and then here's your transversal. Okay, and then what I want you to notice here is that this angle here, the 15x angle, that's the same as the sum of those two angles, the 6x and the 63. So this one's kind of tricky to set up. It's kind of hard to see at first, but the 15x, that's corresponding to the sum of those other two angles, or this big giant angle, if you want to think about that right there. So you're going to say 15x equals, and then 6x plus 63. Alright, and then you're going to subtract 6x from both sides. You're going to get a 9x, I guess, and then equals 63. So then x equals 7 once you're all done. So that one's kind of a weird setup, so you got to be a little bit careful on that. This one right here, another kind of interesting one here. I noticed I got my two lines in transversal, so you have some alternate interior angles going on there. So angle 1 should be 72 degrees. And then also you got another set of alternate interior angles with a different transversal. Notice that those two angles, those should be congruent right there, because those are alternate interior angles right there. So I'm going to go ahead and write 40 right over here as well. Okay, now since you got angle 2, and then right next to it you got 40 degrees. Those make a linear pair. Remember, all linear pairs add up to 180. So I'm going to subtract off 40 and then get the last little bit there. So that'd be 140 degrees right there for angle 2. And then that gives you all of your different angle measures right there. And that is it for our lesson here today.